All right, so let's factor using the grouping method. We use the grouping method when we're factoring a 4-term polynomial. So look at this example here. 1, 2, 3, 4 terms. It's polynomial because it has numerical coefficients, and these are all numerical coefficients, and then they have variables. So you have 3 variable terms and a constant term. So given the steps say, given a 4-term polynomial, we're supposed to divide it into 2 groups. So you go 1, 2, and then put right there, making sure this sign stays with these terms over here. So we divide it in half, and then we look at the front half and find the GCF of the front half. So 5, 5, let's see, what else, and a B. So the greatest common factor comes out. What you have left when you reduce, 2A and 3. Then you come over to the other half and do the same. This has a 2 in common. Take the positive 2 out, and then what you have left goes here. Notice that this is the same exact as here, and if it's not, you've done something wrong somewhere. It has to be the same because the next step says take out the common factor. So this now comes out as a GCF. Remember how that works? You write that in front, and then what's left you put together in the other term, and that's how that is factored. So let's try this again. We have a 4-term. 1, 2, 3, 4. Divide in half after the second one. What goes into the first half? Let's see. They have an A in common and a B. All right, so A, B. What's left? Let's see. That's a 5. Couldn't do anything with the numerical coefficients, so that doesn't mean you don't use the variables. And then the B's go away, so this is 5A plus 4. Go over here. This has a 7 in common. You can also write this down as a clue as to what to take out of up here. So if I take out a 7, a positive 7, you'll be left with the same thing you had here and here. So that comes out as a GCF, and what's left goes back in the parentheses. 4 terms, 1, 2, divide. Take out a y they have in common, so y, let's see, x plus 7. Go over here, kind of helps me to write this x plus 7 over here. How do I make this just a plain x? Well, it has a negative 5 in the front. So this is kind of weird for us. We're going to divide by negative 5 because that's what it's going to take to turn these signs into positive signs here, so these 2 terms are the same. So feel free to do that. So this is going to turn into the greatest common factor is x plus 7, and what's left goes there. All right, so this one, this one, this one, that one. There's 4. When these get all mixed up on the test, you're going to have 2, 3, and 4. So we want to make sure we're working with a 4, so we can go straight to the grouping, dividing it in half. Let's see, this is going to be what, a 2A? So 2A, what's left? 6B minus 7. 6B minus 7 is what I need over here. So I look up here, and I don't have anything to take out, but the signs are wrong. So what I do need to take out is the negative 1 to flip the signs, to change the signs, okay? So that's the only way I'm going to get this as a common factor. Do not change this. If this is what I got in the front half, this has to be what's in the second half. If it's not, and you can't make this other do that, then it's either out of order or you've done something wrong. So we'll talk about the order thing in a moment. All right, so that was the greatest common factor, and then 2A minus 1. All right. This one's kind of strange looking, but let's treat it the same way. It doesn't look like a 4-term polynomial. It looks like one of our warm-up questions. It sort of is. If we distribute this all, we would get one. Let's see, this is x squared minus 7x plus x minus 7. That's a 4-term polynomial, okay? But either way, if it just says factor out the greatest common factor, you just put your line under here. That certainly is the common factor, right? That comes out, and so if that's the greatest common factor, that goes here, and what's left is an x. And what has to be here that you just don't see is a plus 1. You have to put that plus 1 so you could FOIL this back. If you FOILed it back, you would get your 4-term, okay? Every now and then, though, I noticed in the homework there is one that changes the order. So when you go to divide it in half, it kind of works fine. Let's see, y for y. So 4y, oops, it's a y, 2x minus 3. And you go over here and you write 2x minus 3. And this is out of order. So if you think about that for a moment, if I put this here and this here, and divide it by what? Divide this by 5, and that by this by 5, you will get your, so positive 5. Oop, no, negative 5. Because that's negative and that's positive, I need those to be backwards. So negative 5. That will get what I need to do. So you can change the order of the 4 terms. 4 terms, sometimes you need to change the order. When we do the 3-term, we're going to put it in exponential order, with one exception there too. So be aware that sometimes you need to flip something around, change the order of things to make this come out to this. Remember I said it had to. So our final answer is that, and we can always, if we're not sure, we can always check. That is 8xy minus 10x minus 12y plus 15. And if you look up there, you will see every one of these numbers in a different order, but that's okay as long as they're there. Okay? All right, so let's practice a few of these. Go here, put the line through. This is 8x at least. Let's see, let me check. Oh, I got 2 x's there. The 2 x's are the least number, greatest number of x's they have. Look at my key just to make sure. All right, if I take that out of the front half, I'm going to have 5x minus 1 left. Remember, when the whole thing crosses out, you have a 1. Don't make it a 0. And then I go over here and write the same 1. And then look up here. What can I do? Let's see. Definitely a 5 coming out, but the signs are wrong. So maybe a negative 5 would come out. So 5x minus 1 times 8x squared minus 5. Wait. Yes. My key doesn't have the square on it. Let me fix that. Oh, because my handout has different numbers. It works fine that way. That's okay. So apparently at some point I may have changed this problem to, okay, it's, so you may or may not have that X on there. Sorry about that. Either way, you know how to do that. So some of you just have a square instead of the X there. Sorry about that. All right. Oh, and I did this one too. So this should be 3r squared minus 2r minus 9r plus 6. I believe I changed that to that, so I'll have to check this PDF here. Okay, so let's see. R is in common. I guess I gave you a lot of reverse the signs because that is really a tricky thing. All right, and then it changed the order one. Now, how I do that is I notice there are some y's and there are some x's. So I'm not really sure where to put this, so I'm going to put that at the end. And I could just move the y over, and let's try that. Divide it here, take the y out. And then go over here. Can I get x plus 4 out of this? Well, I know I'm taking out a negative, and if I take out a negative 9, that actually will work. Negative 36 divided by negative 9 is a 4. So y minus 9 and x plus 4. Okay, does it matter if I put this term first and then this factor? It does not. So either way, that is accepted. All right, same with this one. This looks a little out of whack because my eye goes to the fact I have some squares here. Is there a wrong way and a right way to put them in order? Not really. Not as long as, let's try that. As long as you divide it in half and you can find something that's the same, you've done it correctly. If you can't find something that's the same, like if I just went like this, there's no way I can make something over here. Look, when I do that, there's no greatest common factor between those first two terms. So something's wrong. And they wouldn't give you the problem if you couldn't do it. So try to rearrange it the best you can. So something, at least start with something that comes out. And then write it over here and see if you can make it do it. If you can't, you need to rearrange it a little bit more. Okay.